Hello everyone. Today I will be talking about predicting forest fires using machine learning models. This is part of my business analytics and artificial intelligence subject. The project aims to estimate how much area gets burned in forest fires in Portugal based on weather data. And also, we created a report as a group assignment, and I'm going to do the presentation individually based on that report. Now we are on slide 2, summary. So I tested 5 different models: random forest, decision tree, support vector machine, artificial neural network, and also the k-nearest neighbors. The artificial neural network, or ANN, performed the best with the smallest error of 4.8. This result could help firefighters allocate resources more effectively. So next we are going to move slide 3. Slides 3 about introduction and objectives. The goals of this project was to create models that predict the area burned in Portugal's northeastern forest using past weather data. Accurate predictions help manage resources better, prevent fires, and respond quicker. This can save cost and protect the environment. So now we are moving to slide 4. Slide 4 about overview of machine learning models. I used 5 models. So there are ANN, random forest, SVM, k-nearest neighbors, and also decision trees. Each of these models is good at analyzing different type of data and patterns. Then we are moving to next slide. Slide 5 about defining business objectives. The main aim was to predict the burned area using weather data. This helps focus resources, improve fire prevention, and respond faster. The idea is to reduce damage by directing firefighting efforts where they are needed most. Then we are going to discuss about data preparation and exploration. Slide 6 about data preparation and exploration. The data set had 517 entries with 13 variables, and the target was the burned area in hectares. There were no missing values, but I removed 4 duplicates to improve accuracy. I found out strong connections between some variables and fire sites, but the data is skewed, meaning there were many small fires and a few larger ones. I kept outlines to understand the impact of large fires. So then we are going to slide 7. Slide number 7 about data sampling method. As you can see, there are 3 points. I used a method called stratified sampling to ensure that both small and large fires were represented equally in the training and test sets. This helps make the models more balanced and accurate. This table summarizing the performance of different machine learning models based on two metrics, RMS and R squared. Random Forest has an RMSE of 26.50 and an R squared of minus 8.59. Decision Tree has an RMSE of 52.19 and R squared of 0.10. And also SVM has an RMSE of 15.09 and R squared of minus 5.20. ANN has an RMSE of 4.80 and R squared of minus 1.20. KNN has an RMSE of 11.45 and an R squared of minus 3.12. RMSE measures the model's prediction error. Lower values indicate better performance. R squared measures how well the model explains the variable in the data. Positive values closer to 1 are better, while negative values indicate poor model fit. Based on these results, the ANN model has the lowest RMSE, suggesting that it predicts most accurately among the models listed. However, all models have negative R squared values, indicating that they do not fit the data well. Now we are moving to slide 9, final models output and key insights. After testing all 5 models, ANN performed the best with an error of 4.0. However, it struggled to explain all the variations in the data. Key predictors were fine fuel moisture code, Duff moisture code, draft code, and temperature. These were linked to larger fires. And also challenges and opportunities. There were some challenges like low accuracy in explaining all variations, unbalanced data, and not enough diverse features. But these challenges also offer opportunities. Improving data quality, balancing the data set, and adding more features could make prediction more accurate. In slide number 10, business-friendly presentation of results, I used a correlation heat map to identify which variables had the strongest link to the burned area. The variables FFMC, DMC, DC, and temperature showed the strongest connections, meaning they are the most important for improving accuracy. Then we are moved to slide number 11. Slide number 11, model performance summary. The ANN model had the lowest error, meaning it was better at predicting burned areas. However, it couldn't explain all the variations. indicating that more adjustment are needed. Slide number 12, scatter plot for predicted versus actual burnet areas. This scatter plot shows the predicted versus actual burnet areas. The red dashed line represents perfect predictions, and the closer the points are to this line, the more accurate the model is. Slide number 13, practical implication for stakeholders. These predictions can be useful for different groups. Firefighters can prioritize high-risk areas. Environmental organizations can focus on prevention, and policymakers can use the insights to build safer infrastructure. Slide number 14, recommendations for implementing the model. I suggest integrating this model into decision-making systems, improving data collection, and retraining the model regularly. It's also important to balance the data, educate users, and monitor performance to make better predictions over time. These are the references I used in this presentation. Slide number 15, conclusion. In summary, this study aimed to predict forest fire areas using weather data to support better fire management. The ANN model was the most accurate, but there is room for improvement. The next step involves improving data handling, fixing data imbalances, and refining features to support better planning. Before I wrap up, I would like to emphasize the real-world impact of this project. By accurately predicting forest fire areas using machine learning, we can not only save resources but also protect lives and the environment. This productive approach is a step toward smarter, safer, and more efficient disease management. Thank you all for your attention.